yourself if you need to. Yeah. In my classes, sometimes the student will record themselves for their own use. Otherwise, I will record it and I will upload, yeah, accordingly. Okay, so let me kind of refresh on LMC, yeah, Little Man Computers, where we have started last week. Yeah, so this is what I shared with you guys last week, where you need to really understand this wall mail room. I have seen in a past year question here from UOG, where they have used this diagram and they have created questions, yeah, questions based on this diagram. So even though it is a very simple diagram, you think not much of details here that you can ignore. Please don't do that. Please don't do that. In fact, there are a lot of details here that you need to understand, and then you need to compare this LMC diagram, or they call it physical layout, with the computer system. Because our computer system, no doubt whether it is running on high level languages or running on, for GL languages and so on. But the basic concept, the basic idea is still the same, where there is an input and output, there is a processor to do the calculation, there is a memory to store information and data, and also there will be a controller, controller, right, CU, to manage the entire operation. So that's what you see here. You have an input basket, you have an output basket, you have a calculator such as the processor in order to do some simple calculation. You have a storage or you have a mailbox here in order to keep track in which mailbox, what is the contents of the mailbox. And you have numbers to identify each of the mailbox, and you have some data inside the mailbox. And just because this is fully manual, then you need a person, a little man, which is known as a little man computer, LMC, in order to operate this whole operation. And just because you can't remember everything, because for him, the number can be very large. It can be 400 mailboxes, 500, or even less, or even more. So you have a register here, a simple mechanism, a simple tool for him to keep the counting. For example, what is the current job? What is the next job? What is the current instruction? What is the next instruction? What is supposed to do next? Who's supposed to do what? Things like that. Yeah. So he has a simple tool to keep tracking, or in other words, to monitor the task that is performing currently and what task he has to perform next. In the computer system, uh, it's the same. The control unit will play that role. But over here in this diagram, this guy who is known as a LMC will be doing that job. Of course, he cannot handle very complicated tasks, but based on his capability, he will try to manage one at a time. Yeah, one at a time. Because even though we are capable of doing multitasking, but we have to prioritize. Yeah, we have to prioritize one job at a time and follow the priority to complete the task. The same goes to the computer system. Even though we know computer system can do multitasking, but the computer system also works on priority. There are quite a number of mechanisms which we will cover at the later stage. What are the mechanisms the computer system will use in order to manage all the job, which are known as multitasking. Multitasking, yeah. I'll come to that later when we really do some lab exercise or practical exercise. All right, with that, let me move on. The contents of a mailbox are not the same as the address of the mailbox. Yeah, as you all can see, you see the this is the address of the mailbox, and these are the contents. So the contents are not the same as the mailbox. The mailbox are kind of fixed, but the contents varies. It will change accordingly. Example, post office box. Your post office box number identifies where you go to pick up your email, right? Your post office box is fixed, like what I told you last week. Maybe you are staying in second floor, unit number 1, so it will be 0201, for example. But this has nothing to do with your contents of your mailbox. Your contents of the mailbox can be anything. So referring to that, yeah, with that understanding, your recording or your tracking will be something similar to this. You will have the address and you will have the contents. Content may be the content. We are looking at the content. The content may be like what I told you earlier. It could be data, where we're going to use 3-digit number, as you can see here, 3-digit number. Or it also can have some instruction. It can be data, it can be instruction. Again, for the instruction, we're going to use 3-digit to standardize it, to simplify it. So please set in your mind that address is fixed. We cannot change the address. Even in a memory storage, the memory address is fixed. The manufacturer who build the storage will fix the address. Whether there are 1 million cell or 2 million cell, that's what we call the memory size, isn't it? The memory size is either 1 terabyte, 2 terabyte, or less than that. Maybe your hard disk is, for example, 500 meg. So the size is fixed. The address size is fixed. We cannot change. But what we can change is the contents of the storage. Now that is dynamic, very dynamic. But to simplify the whole operation, because if you refer to the memory storage, is very complicated. It can be 62-bit computers or 32-bit computers or 64. So it is very complicated. To simplify the concept, understanding, we make it 3-digit. Yeah, 3-digit. That means this is like a 3-bit computers. Okay, let's look at instruction, because instruction is important. Data, well, is very straightforward. Like here you have 500 is the data, 199 is the data, very straightforward. But when it comes to instruction, like what I shared with you guys last week, it can be complicated. So instruction consists of 2 parts. Remember I told you last week, opcode and operand. Opcode, or we call it operation code. Yeah, opcode, the first part of it. The second part of the content is what we call operand. An example is provided down here, 3 and 25. So in LMC, in Little Man computers, the opcode normally will be represented by a single digit. Yeah, we call it operation code. Where else the operand, yeah, it can be like 2-digit, because total is 3-digit, isn't it? Total is 3-digit. So operand will be 2-digit. Yeah, 2-digit. So total will be 3-digit. Total, as you can see, is 3-digit. 1 digit here, 2-digit. Okay, next let's look into memory. So what we're going to do, we're going to take this content and then we're going to load into the memory address. Yeah. So in the LMC, it is something like you put into the in basket. All right. Also, I did introduce to you what is programming language last week as an introduction. We did not go into the detail. Okay, before that, let me see if there is any message, because sometimes the message will pops up and I don't know about it. Let me see if there is any message. All right, so far all of you have typed where you from. Okay, that's good. For latecomers, I see not all of you have signed in or so-called type here. For whoever joined late, please type either KL, Penang, or LJ. Okay, kind of your attendance, so that I can keep track. For latecomers, whoever, I know some of you joined late, so whoever came late, just type so that I can pick it up later as also another evidence of your attendance. Of course, we have attendance in Blackboard, but it's another attendance, another attendance. All right, let me continue. What is assembly language? For those who not familiar or not very sure on what is assembly language, maybe you have never experienced or you have never seen one. I myself, I started my careers with assembly language those days, many years ago, 20 over years ago. It is a very low level programming language. Those days I learned programming language using mainframe computers. Remember last time we called three categories of computers. The first we call it mainframe. The second we call it mini computers. The third category we call microcomputers. Now we don't call computers by these categories anymore. We just call it client or server. Server, there are many versions or types of servers. Maybe most of you do not know what are the servers available out there. But we just refer all those servers as a servers, or we call them as Windows servers, Linux servers, IBM servers, HP servers, mid-range or cloud servers. So there are a lot of new terms are coming up now. We call it virtual servers and so on. And then the computers, we call it PC, laptop, microcomputers, and more devices. More devices are getting smarter right now. So we call it IoT, or we just call it devices. So assembly language is a low-level programming languages where human beings started with assembly languages. Very first language, just one level higher than the machine language. Machine language, as you all know, is 1 and 0. So assembly language, like what I told you guys last week, it is also known as a symbolic language, where we use symbol to write the language or the programming language. Very specific to CPU, meaning it is CPU based or CPU dependent. IBM CPU will run IBM assembly language. HP CPU will run HP CPU language. That's the reason last time we have IBM DOS, PC DOS. IBM DOS for IBM machine or IBM manufactured machine. PC DOS mostly for Microsoft based machine. Later on, when Microsoft bought over the PC DOS or the DOS from IBM, they changed everything to MS-DOS. MS-DOS. They call it Microsoft DIS operating system, which was the very first operating system, as you all should know. And it is one-to-one correspondent between assembly language instruction and machine. It's one-to-one. That means if you have one instruction in assembly language, it will be converted to one instruction in machine language. Not like what we have today. Today we have a very high level language, 4GL, 5GL, where it has to be converted using assembler or using compiler in order for the machine to understand, and it has to go through many layers or many levels of conversion before can get converted into machine language. But from low-level languages, assembly languages to machine language is just like one layer. And remember I told you guys, it is also known as a symbolic language, or we call it mnemonic. Mnemonic means it's a combination of digit and symbols. or we call it short character sequence, used by the programmers whenever they need to control the hardware. Example, the device driver. So, if you are interested to become a so-called firmware programmer, hardware programmer, which the demand is very high today, for example, to do programming for a circuit board, to do programming for the controller board in every device, TV, vacuum cleaner, washing machine, our handphone, all these are the hardware, right? And all these devices, there are what we call electronic boards or hardware board or controller board. In order to do programming onto this board, you cannot go and use Python, for example, or you cannot go and use C# because all these languages need to be converted, and that conversion cannot take place or cannot happen automatically. So that's the reason why these hardwares are still being programmed in what we call low-level languages, yeah, such as assembly language, or we call it firmware. And one of the high-level languages which can support similar functionality or requirement is Java language. That's why when you buy Toshiba machine or you buy, for example, vacuum cleaner today, it is labeled or it is written as a Java enabled. Reason Java is one of the type of programming language where it doesn't need actual conversion. It runs immediately on hardware, or we call it machine independent language. Machine independent language. That means it doesn't depend on hardware or the platform. It can run on any platform. So that is Java. That's one of the reasons why Java is very popular. But to learn Java is very difficult. Huh? Java is a very complicated language. The same goes to assembly language. It's quite difficult. Like for example, if I ask you to learn machine language, it's going to be very tough, isn't it? Who can remember 1 and 0? Only the computer understands 1 and 0. So what we as a human being we have done is we converted machine language into assembly language. How we convert? That's what we learned in number system last week. A is 10, B is 11, C is 12, and so on. And to make it even easier, because there are more characters on the keyboard, yeah, because there are more characters on the keyboard. Okay, I know some of my students, they love this. I would like to ask questions. Type in your chat box, how many characters are there on the keyboard? Type on the keyboard, type on your chat box, how many characters are there on the keyboard? Standard keyboard. Just type, I want to see anyone, volunteer. How many characters are there on the keyboard? If you don't want to type, you can unmute it and you speak to me. Come on, I don't see anyone typing. 101 characters. Okay, that's very good. Other than that, 104. Okay, good. I already see some. Yeah, that's very good. Okay, so standard keyboard, we have 101 characters. But if you buy some special type of keyboards for the game or for accounting and finance purpose, you may have more so-called keystrokes or button, isn't it? So all these buttons need to be represented, right? We have home button, we have page up, page down, and button, we have symbols, we have F1, but we have only 26 characters and we have only 0 to 9, which we cannot represent all, isn't it? We cannot represent all. So that is the reason what happened. ASCII, let me type if you're not very sure. ASCII. Anyone knows what ASCII stand for? Type. Either you unmute and speak or you type. What ASCII stand for? All of you as a IT computer student, furthermore you are a degree student, I'd like to challenge you. You must know what is ASCII. I remember.
American
Again?
American Standard Code for Information Interchange.
Very good. That's good. Okay, beautiful. All right. So we need to know ASCII code. Download this template. Download this template from the internet and keep it with you. Keep it with you because when you do coding, sometimes you have to use or create your own characters. Then you can refer to this table to come out with that characters. Yeah. So it is an American Standard Code for Information Interchange created by American for the whole world. And this is very useful. Remember I said A in the ASCII table is equivalent to what value? Can anyone type A is equal to what value? A in American, some said 10, some said 11. A in ASCII table equivalent to what value? ASCII table, I'm not referring to base 16. ASCII table. Zen type 97, Kasturi 1010, 65, that's correct. Yeah. Kajendra, you got it right. A is equal to 65. For those who have downloaded the table, ASCII table from the internet, it is free. You can download it and save it. A is 65. Yeah. Of course, I can share with you. I don't have with me now. It's in my computer. So you can always search from the internet and keep it with you. So A in ASCII table is 65, B is 66 and so on. And don't get confused that characters on the ASCII table is not base any, not related to base. That means not base 16 or base 10 or base 2. It is purely a character representation. For example, you have F1 on your keyboard. So if you want to know what is the value of F1 on your keyboard, you go to refer to ASCII table. And then you have this, for example, this ampersand. Yeah. So you want to do programming. So you must know what is this ampersand, the value of this ampersand, so that you can write in your code. So you must refer to ASCII table. And then if you use Word, for example, in the Word, yeah, let me open Word, for example. Yeah, blank copy. And then you can insert, isn't it? When you insert all these symbols, when you insert these symbols, I hope all of you can see my screen. If you cannot, you let me know. When you insert this symbol, you think the computer can understand this symbol? The computer cannot understand this symbol. What is this symbol? Yeah, computer cannot understand this. Yeah, computer won't understand this. If the computer can understand all this, the computer can talk to you, right? Or you can talk to the computers. No, the answer is no. The computer cannot understand all the symbols. So what you got to do? You got to represent all the symbol in a table and give a number. For example, if you refer to ASCII table, what is this number? There will be one number. For example, maybe 112, for example. I don't know, I'm just guessing. So this is how we do programming. So when we use alternate 112 in code, in our code, the character will appear in your output is this symbol. So that's how we do programming. So if you ask me how the ASCII table will be helpful to you, that is through when you do programming. So ASCII table is very important. It's not my intention here to go through the ASCII table with you, but the ASCII table is very important for programmers. Okay, let me come back to instruction set. Going back to assembly language. So remember, instruction, the content will be, or the instruction will be in 3 digit. Yeah. The first digit will be for the, okay, let me show you again, opcode, and 2 digit will be for operand. Yeah, that's how we're going to understand this instruction. All right, so what are the operation code? Yeah, if you look at this, first is operation code, isn't it? 1 digit. So operation code, what we have, normally we have arithmetic, plus, minus, division, multiply, and so on. That is what we call operation. Those what we call operation. We can add, we can minus, we can divide, multiply. And in symbolic, in mnemonic or symbolic, when you add, you call it ADD. Yeah, so these are the 3 characters that we're going to use in assembly language for addition. For minus, we're going to use SUB, subtract. And the same, you will see more later for multiply, for division, and so on. For data movement, to move data, we're going to use symbolic or mnemonic such as store, load. What's the difference between store and load? Store is like save. Load is like you upload, download, you move data, for example. Load to into box, load into input box, or unload from input box into something somewhere else. That is the meaning of load. And then input output is very straight. We have input and output. And then we have some machine control. We call that halt or COB, coffee break. Or we call it control on branch or control on break, something like that. COB. So this is symbolic. Quite clear, straightforward. Add means we know to add numbers, to add value. Subtract means to minus. Store means to save. Load means to upload or download. To add, like to add on or to remove. Input, output, I think you guys understand very clearly. And then to stop, halt, and then break. This is what we call mnemonic. And in assembly language, we will use numbers. Remember the 3 digit? The 3 digit I told you earlier here. The 3 digit here. We will use numbers such as 1 something something to add, 2 something something for sub, 3 something something. It can be 101, for example, 102, 103. Yeah, you can start with a proper sequence, up to you. And then anything start with 201 will be subtraction and so on. Then anything start with 3, normally we used to store. Anything start with 5, we used to load. And this is quite pretty standard in assembly language. You will see that in all the examples later, we use pretty standard this sequence. And anything with 901 will be for input and output. 000 we will use for halt. And for break no numbers, we just use COB. So please remember this, please understand this and remember. But you will see this again and again in all the examples that we're going to discuss after this. So these are the format of instruction set in assembly language. Yeah. Okay. With that, any question?
No question, sir.
Okay, good. Let me see whether there is any other comments. Okay, if no, let me continue with the next slide. All right, so here we have move data between calculator and input-output basket without using the mailboxes. If I go back to the LMC, what is happening now is between the inbox and the calculator. So this guy going to do some tasks, moving data from inbox to calculator and maybe to the output. Over here, the operation going to be over here. without involving the mailbox. When you do that in computers, we are doing that in computers today, even though you have very high-end computer machine or laptop. That is when you type from keyboard, it goes straight to your display. And that doesn't mean that you have saved the data. No, not yet. It doesn't go here yet. What you type is what is being displayed. Yeah, being displayed means being displayed into the screen in our system. Over here, what you type goes into the calculator. The display of the calculator is considered output. You can like, hey, I get number 1, 2, 3. The guy maybe will print out this 1, 2, 3 and put it here. If the calculator got a printout lah. Otherwise, he will come and tell you, hey, the output is 1, 2, 3. Okay, you will put here 1, 2, 3. For whoever need to take the 1, 2, 3. Okay, so it doesn't involve the mailboxes. That is what it's trying to do over here, this example. Move data between calculator and in-out basket without using the mailboxes. So operation code, remember 9. Why 9? Input output start with 9. You see the 9 is bold. So we use operation code 9, and for input we use 01 and output for 02. So that's how we use it. That's how we use it. So when you look at 901, without all this, when you look at the number, you know 901 means there is an input. 902 means there is output. This is how we understand. So the next time you see 901, you must understand it is an input. You see 902, you must understand it is output. You 01 something something must be at 2 something something sub. Yeah, that's how we can understand the assembly language. See, so this is input and output 901, 902. So now you can translate this diagram into 901, 902. 901 is input, 902 is output. Okay, let me move on. So between mailbox and calculator. Okay, now we're going to take a look at the example between mailbox and calculator. That is, if you look at the diagram, is over here between these two, mailbox and calculator. Calculator is equivalent to our CPU in the computer system. Mailboxes equivalent to our storage, yeah, storage, memory in our computer system. So operation code for store start with 3, isn't it? If you don't know, refer back to this. You see, store start with 3, load start with 5. Yeah, store 3, load 5. And then this depends on the address. It can be any mailbox. It can be 001, it can be 399. Where you want to store. Yeah, where you want to store here is up to you. You can store here 301, 302, 303. This is what we call address, isn't it? Mailbox address. We are not worried about the content, the address. So this is operand or address, the 2-digit. 2-digit is good enough for us now because like in one floor, don't tell me you have 100 units of houses. No, in one floor, the most you have 20 units, 30 units. So I believe this is more than enough. This is more than enough. When the floor change, this will repeat again. Right? I hope all of you agree with me, yeah? When the floor change, this will start all over again, 01, 02, 03. Then we know it is a different floor, 01. Maybe we can start with 301, 302, 303. Then we stop. Then next floor, we start with the different numbers. All right? Okay. So we load. LDA means load data, isn't it? There, load. So the short form that we're going to use for load is LDA. For store, we use STO. We don't want to use all the 5 characters. Remember, I told you we use only 3-digit, either numbers or mnemonic symbols, only 3-digit. So you see slowly they already start using 3-digit. Store, STOLDA, load. Okay, so far I think all of you can follow me, isn't it? All right. So you have load and store. Yeah, load the data from the mailbox to the calculator. Once the calculator generates some output, you store it back into the mailbox. So this is exactly what is happening inside the computer system. All right, with that, let me move on. Read the mailbox. Arithmetic operation, another example. Arithmetic operation. Let's say you want to do calculation. I would like to, normally I ask this question to all my students in the class. For example, 2 plus 2 equal to 4. How you do that? It's not that easy, yeah? It's not that easy. 2 plus 2 equal to 4. How the computer does that calculation? It's not that easy. It's not that straightforward. But before we go and take a look at how the computer does that, let's take a look how the LMC does that. How the little man computers does that. So he has to read the mailbox, perform the operation in the calculator, and store back. Yeah, store back into the mailbox or simply display on the calculator. It depends on the instruction, right? It depends on the instruction. So the instruction says just do the calculation and display. You just do the calculation and display. If the instruction says do the calculation and store back into the mailbox, you do the calculation and you do store back into the uh, mailbox. It depends, you must follow the instruction. So the instruction here, add. As you know, one is add, isn't it? Add any numbers from any mailbox. And then the second instruction is to subtract. Sub means subtract, huh? Subtract something from that value, for example. For example, 4 minus 2. So you store 4 here and then you subtract 2, for example. So that value will be here. For example, 10 minus 7, you get 3, you store the 3 inside this mailbox. So that is operation. Or if you have instruction like 2 plus 2, 2 plus 2, 4. You store the value here, 4, in this mailbox. Yeah, in mailbox, for example, 105, you store the number, the value out of that operation. And then the next instruction says sub. Let's say your answer earlier is 7. 7 minus 3, 4. You save that 4 inside here. So that's how this operation will be performed. Arithmetic or example, add and subtract will be performed. All right. Okay, with that, let me move on. So I have just shown you how add and subtract are being performed between the calculator and the mailboxes with the help of little man computers in this LMC. In the computers, of course, you type on the keyboard, the processor will do it, and the processor will save it onto the memory. If you type save, if you don't type save, the processor will just display on the screen. Yes or not? Remember when you use your keypad or keyboard to do calculation, for example, it is just a simple operation. It doesn't mean it is safe. Yeah, it doesn't mean it is safe, right? Unless you press the save button. You don't believe me. For example, let me show you one example. Let me close this. Okay. Oh, sorry. Let me open a blank sheet. Okay, for example, let's say you type 2 plus 2, yeah? So when you type 2 plus 2, you type for me yes or no on the keyboard. I know I'm going very basic, but like what I mentioned earlier, this course is very basic. This course requires you to understand the very basic. Otherwise, if I ask you a very basic question like just now, I ask you what is the value of A in ASCII table, I'll get all kind of answers. So when I type 2 plus 2 on the keyboard, all of us know the answer is 4. But when I type 2 plus 2, is this 2 plus 2 safe in the memory or it is just a display on the keyboard? If just display on the keyboard, type yes. If you think it is safe, it's already safe on the memory, type M. If we think when I type 2 plus 2 on the keyboard, it is just a display characters on the keyboard, type yes. All right, I see all of you are typing yes, that means you understood very well. All right, when it will be safe? When it will be safe? Okay, let me go back to the Excel file. When you total this up, remember, when you total this up and then you get a result, for example, let's say, for example, result is 4. Yeah. And then when you click this button, this is save button. Only when you click this save button, this result will be saved onto the memory. Otherwise, you see, you will ask the question, save or don't save. I don't want to save for now, so it got nothing to do with the memory. That is what this computer is trying to do now. I can do anything here, but if I don't save back into the mailbox, it is just temporary. Yeah, it is just temporary. So the same goes to your computers. When you type something on your keyboard and then you don't save it, it is temporary. That's why we have RAM, random access memory, which is temporary. When you switch off your computers or when you shut down, everything will be erased off. But if you want to save that value, then you have to give the command save, and then that value will be saved onto your permanent storage hard disk. So I hope, even though this course is very basic, the purpose of this course is to give you a very clear understanding how the operation of the OS, or how is the operation of the computer system. Why we have to go very basic? Because if you're going to work as a hardcore hardware programmer, you need to know how to do programming at the hardware level, machine level. Remember, I did mention about firmware. That is the reason. Yeah, that is the reason. So with that, I hope you understand how we do add and sub. Add means adding some characters or value into a mailbox. Sub means we are minusing it from the mailbox. Of course, we can load into the calculator to do the processing, and the output we save back onto the mailbox. Yeah, like what the instruction here. Load, then we save back or we store back. We don't call it save, we call it store in LMC. But in today's world, we call it save. Human beings started with numbers those days. Today, of course, you can save video, audio, numbers, text, and so on. But not last time. Last time, the computers only can accept very simple characters. Okay, let me move on. Instruction so far, what we have covered? We have covered load and store. We have covered add and subtract. We have covered input and output. We have not covered coffee break yet. We will take a break later. That is our coffee break. So the rest of the instruction we're going to cover after this. Yeah, after this. I hope so far no question. With that, let me move on. So now we're going to take a look at a very simple program. How to add 1 plus 1 equal to 2. Or like what I mentioned earlier, 2 plus 2 equal to 4. How the computer does that, huh? How the computer does that. You need to understand this simple program so that you can start writing assembly language at the end of this lecture. Okay. What is the program all about? Assume data is stored in a mailbox with addresses more than 90. So mailbox addresses is more than 90 now. Then we write the instruction. Okay, we write the assembly language. What we're going to do, we're going to input one number. We call it input A. And then we store that value. You input in basket, remember in basket? And that number need to be stored. Stored in a mailbox. Yeah. Then we input another number. So we have two numbers now. So the two numbers need to be added. That is, for example, you can see the picture here. Input, why they use A and A? Because they use 1 and 1. If you use 1 and 2, then you can say A and B. But here they use the same number. Input 1, store. Store means plus or add. Input another number, same number A, which is 1 in this case. And then what is the operation? Add. So you have two numbers in the mailbox. The operation code is add. ADD. And then output the number. Output the number. So very simple program, isn't it? Input one number, store the number. Input second number, we add that two numbers and display the output. I hope all of you can follow this, very simple add two numbers program. So let's look at that in a more mnemonic or systematic way, by using mailbox, code and instruction description. In the exam, in your exam, this is what they will give you. They will ask you to write. They will ask you to write this code. What is the code? Yes.
I have a question. Okay, now when we input the first number and then we store the data, right?
Yep.
Why when we input the second number, we don't store the data?
Like what I said earlier, you're not going to save this whole operation. This whole operation is temporary.
Oh, okay.
So you just want to display like what I did on the Excel just now. 2 plus 2 equal to 4. You just use the memory. You just use the processor to calculate, but you are not using the memory.
Okay.
So if you want to save it, then you need to store this number also.
Okay.
Right now you're not using the memory. It's in between the processor and the display. That's it.
Okay.
All right. So in the exam, they will give you a table like this. Yeah, let me tell you, in the exam, this is what they will give you. They will expect you to create your own mailbox. So you can create such as this 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so on. And this is your wish. You can create any numbers. Start from 00 up to 99. Because normally mailboxes, remember I told you 2 digit is good enough. This mailbox is not so important. Not so important, but you can always start with 00, go all the way until 99. But the code is important. The code, you must refer to the code that I gave you earlier, like this. This code, remember this. This one. Add normally start with 1, sub 2, but don't worry, they will give you. They will give you also in the exam. So sometimes they will give you, sometimes you can create on your own. So mailbox 00, the code is 901. 901 means you know already is the input. So you can write in the input instruction, input first number. And then what you got to do next? The next instruction is to store this number. So store, you can use 399, for example. So what is the meaning? You are storing this value at, 3 is store. You're storing at maybe mailbox 99. It can be like that, or it can be your own mailbox, doesn't matter. Any mailbox, huh? And then you have another mailbox number 3. What is the instruction at mailbox number 02? Input second number. That is the instruction. So now you have two different numbers, first number and second number. What is the mailbox number 4 or 03 says? 199. That means add the first number to the second number. Yeah, add. So you will get the output. Where you want to store the output, we store at mailbox number 4, 902. Yeah, 902 is output. Remember, 901 is input, 902 is output. Output result. So whatever the first number and the second number, we don't know, but the output will be stored in mailbox number 4. And then you stop, halt 000, and you store the data, the output. The output into 902. And if you want to save the data, you can always save it. Normally in a program like this, we will store the data into the last mailbox 99, just in case. Yeah. So you will have one what we call a mailbox for the data, because remember I told you this is not permanent. The first number can be any number, second number can be any number. As long as there are two numbers, your program will add the two numbers and display the output and stop. So this is what we call assembly language, mnemonic or symbolic. For the computers doesn't refer to the instruction description. The computers only refer to the code. By looking at the code, the computer will understand what the computer is supposed to do. 901 means input one number. 399 means store the data. 901 means accept another number. 199 add the two numbers. 902 output the output, the result, and then stop. So the computer only will understand this, the operation code and instruction. So this is what we call assembly language. The code is what is important. Mailbox is simply for us to understand where the operation is taking place. Instruction is for us, for human being to understand what is happening inside the code. Any questions, guys? Any question? Okay, let's look at more example. You will be you definitely will understand after this. All right. If anyone needs a break, let me know, because I've been going through already 1 hour now.
I should need a break.
Okay. All right. I think if we need a break, we take a short break. Let's take a 10-minute short break. So I'll see you all at maybe around 4:12. Let's take a short break. 10 minutes. Okay, guys, sorry. Okay, let's continue on. I hope all of you are back. Let's continue. All right, so program to add two numbers, that's where we stop. So I hope all of you are clear. 901 is input first number, 399 to store the first number, 901 to add another number or input second number, then 199 to add first number to the second number, 902 is output the result, then we stop the program. Yeah, so that's how it works. So let's look at more example. So now we want to add the two numbers using mnemonic. You see the difference between this slide and this slide. Here we use code. Remember I told you we use code, assembly language code. Like for example 901, you understand what is 901, 902 and so on. So instead of using code, the other option is using mnemonic symbol. Yeah, symbol like this. Same program to add two numbers using mnemonic. So you have the same mailboxes here, same instruction. What you have different is you are using mnemonic instead of code. So in the exam, you have an option either to use code or to use mnemonic. You don't have to use both. You use either one. Remember, you use either one, whichever you find easier for you. Either you use code or you use mnemonic. Of course, you can use both. No one will stop you. No one will say it's wrong. But you have an option that you just need to use one. If you ask me, I prefer mnemonic because it's much more easier to understand compared to code. Code you have to remember what is 901, 199 or 1902 and so on. But over here you don't have to remember number. You remember the mnemonic, the symbol, remember? For example, at mailbox 00, I do in, mean input the first number. Then I store at 99. Yeah, store at 99. For example, you see, you use 399. 3 for store, 99 means you store at 99. Why 99? 99 is where you store your data. Temporary, yeah, not permanent, temporary. 3 mailbox 99, you store your data. So the same, store at 99, you store the value number 1. Then you input second number. Again, you add to the first number because it's 99, you see. This mailbox 99 cannot hold two data, only can hold one data. For example, if you add number one first, this number one will go here. Then when the second number comes in, it will overwrite the first number because it's the same mailbox. So the second number will overwrite. So in terms of operation or mnemonic, what is happening is add 99. So add the first number to the second number. So 1 plus 1, you will get a 2. So output the result 2 at mailbox number 4. At mailbox number 5, you stop. Yeah, coffee break or break, and then your data will be 99. So if you ask me, I prefer mnemonic. It's much more easier to understand compared to code. So as I told you earlier, you have an option. Either you can use code to write your assembly language or you can use mnemonic. Okay. I hope you understand such a simple program in writing assembly language using two different formats, either code or mnemonic. Okay. All this while, we are not involving the memory. We are not storing the data, just temporary. Meaning we are just dealing with the RAM, random access memory, not with the hard disk. So your data is temporary here. You switch off the computers, everything will be blank. So let's understand data storage location, which is we are referring to hard disk, yeah, or your secondary memory. Physically identical to instruction mailbox, not located in instruction sequence, identified by DAT, data mnemonic. DAT means for data. Simple program. Another example, but this time we want to subtract two numbers. Like you can see in the drawing, the diagram, the girl is trying to do 4 minus 2 is equal to 2. So how to do this program or how to write in assembly language? Input two numbers, subtract the second number from the first and output the result. This is your so-called task that they give it to you. Task, input two numbers, subtract the second number from the first number and output the result. So this is what the question is. And then they will ask you to write the assembly language, assembly code in order to fulfill this task. So that's how your question will be. They will give you a task and then they will ask you to write the assembly language. Okay, example. Mailbox 00, mnemonic in, input the first number. Then you store the first number. You see now they store in 98, not 99, 98. They use 98 first. Store in box 98. Then input the second number, they store in 99. So now you see the two numbers are being stored in two different mailboxes. One in 98, the other one in 99. Then load 98. Load value from box 98 into the calculator. So you take the value from the 98, you put into the calculator. Then subtract 99. That means you take the value from 99, you subtract it from the first number. Subtract value from 99. Yeah. So that's how subtract works. Subtract value from box 99. And then output the result. Then you stop. Example, let's say you stop 4 here. 4. Input first number is 4. Then the second number is 2. Yeah, 4 and 2. So what you do here, you subtract 2 from the 4. Subtract value from 99. Subtract 2 from the 4, you get 2. So you display 2. Yeah, that's how it works. Load value from 98 into the calculator. So the calculator will have 4 now. So subtract 2 from the 4, you get 2. You store the value here and then you display. So that's how subtract works. Any question on this program, assembly program sample 2?
No questions.
Okay, good. All right, let me continue. Program control. So far what we have covered, how to input numbers, how to add numbers, how to subtract numbers using assembly language. Next, how to program control, break. This in today's programming language we call, from the main program we pass the flow to the sub-program or to a function. In order to do a sub-function, then return the control back to the main program. So far, the instruction must always be executed in the exact sequence. Yeah, in every program, Doesn't matter whether you write Python or C or C# or whatever language it is, there will be a program control. Program control is the flow of your logic. If there is no program control, you will get a runtime error. So what we are trying to do here is we start and then we end correctly. And if there is a loop, we go inside the loop, perform all the loop, following the control structure. Once done, we exit, we stop. Wherever there is a branching, we follow the branch. That is how program control works. I think I don't have to explain this further because all of you are IT student. You have done programming in your diploma, in your foundation, so you understand very well. Okay, coming back to assembly code, what we use for branch. For BR or branch or jump, we use 6. Operation code 6, then address, follow with the address. Branch on 0, BRZ means branch on 0. That means whenever the output is 0, you branch it out. That's the difference between this and this. This one simply branch out, exit. This is only branch out if the output is 0. If you want to use opcode, we use 7. This is branch on plus, positive, positive. If the value is positive, you branch out. Normally we don't use this. All the time we use BR or BRZ, but sometimes if your output is plus, positive, you also can branch out. Then you use operation code A with operand address. This is simply to stop. So if you use COB or HLT, you stop the program. You guys have seen that here, isn't it? It is stop. So you must have this command as a last command in your program, end of program. All programs must have that halt, before the data. You got to have that. Otherwise, it's like you're not terminating your program. You're not stopping your program. Going back to the earlier example, if you use operation code, these are the numbers. If you use mnemonic, these are the code or mnemonic. Okay, so here you have the full instruction set. Add, subtract, store, load, jump, BR, branch. Branch on 0, branch on positive, input, output, halt, and break. Okay, that's what we have covered so far. Okay, loops in LMC. Load 90. This is load 90 means so you store this value at mailbox 90, for example. That is the meaning. 90 is assumed to contain some value. The mailbox 90 will have some value. Or if you use numbers, code, you can use 590 because 5 is load. So 590 means load mailbox 90. Branch, when branch if the output is 0, where to branch? Branch to 48, mailbox 48, branch to here. Must pay attention because your program will be like this. Branch 48 means you branch from mailbox 46, you branch to mailbox 48. That is the meaning. Branch to 60 means you branch from here to 60. This is what we call loop. Break at 45, you break. You break at 45 means you go here and you break. So that's how things need to be understood when you look at all this. That's the meaning. That's why I say this is a bit difficult to remember, easier to remember mnemonic.
Sir?
Yes.
In this LMC, does it have a table including?
What do you mean by table?
Does it have a show table so I can understand about what is LDA 90?
Oh, okay. In the exam, they do provide you that. In the exam, they will provide you this.
Only provide this full instructions.
Yes, they will give you the instruction. So for those who are not, you don't have to memorize actually. So you have a choice either to use the code or you use the mnemonic.
See, thank you.
Yep. Okay, so here we have a task, quite a complicated assembly language. Yeah, for now. Find positive difference of two numbers. That means it's like subtract the second number from the first number and whether the value is positive or negative. That is the whole idea. For example, 4 minus 2 is positive. If positive, what you do? Or if 2 minus 4 is negative 2, isn't it? If negative, what you do? That's the whole idea. So let's go through this line by line and then we will try to understand. Okay. What do you understand from this? This is a mailbox. You see, mailbox is very easy. 0, 1, right up to 11, because there are 11 instructions. This is your mnemonic, this is your code. Input first number, store the first number in mailbox 10. So you store here. You see, this is the first number. Then you input the second number. Yeah, 901 is input. You store in 11. You store here. So you have two numbers here. First number here, second number here. First number you store in mailbox 10. Second number you store in mailbox 11. Yeah, so you store 11. You store 11. Yeah, and then you subtract 10. That means you take the value from the store 10, subtract 10. Subtract 10 means you take the value of 11, subtract to the value of 10. Yeah, that's what the instruction here, subtract 10. Then you do a test. The instruction says so. If positive, you do a test. What test? You branch out to 08. If the output is positive, you print result. 902 output, isn't it? You output out, you print the result. Branch on positive. For example, if the first value is 4, the second value is 2, when you do the subtract the second value from the first value, you get 2. And that is positive. So over here. Yeah. Subtract 2 from 4, for example, you get positive. Positive, you go here and you print out the result. If negative, if the value is negative, you load 10. You load the new value into this value. Yeah. And then what the next instruction is subtract 11. That means you take the new value from the load 10. Next, you subtract 11. Whatever value you have here, subtract this value from this value. Okay, if negative. So that's how you want the program to do. So then you actually print out the result and you stop. So there are two operations here. One is whether to check the value is positive or the value is negative. So that's how you write assembly language. And with that, now you understand how to input the first value, store the first value, enter the second value, store the second value, subtract 10. meaning whatever value you have in 10, you subtract it out from the second value and see what is the output. And if it is negative, for example, 2 minus 4 is negative, yeah, it's negative, then what you do next? And output the result and you stop. Yeah, an example of how to find positive difference of two numbers. Okay, any questions so far? We will do more example. Don't worry if it is a bit confusing for you today. We will do more examples during the tutorial and also in the past year exam paper. Yeah, so don't worry too much. This is very simple.
Okay.
Right, we're going to continue. We're going to continue. We still have, let me see. Okay, over here, any message? No message. All right, no new message. Let me continue. I hope all of you with me, yeah? I'll come back to you shortly. Next, what we're going to cover is what we call instruction cycle. Instruction cycle. So things going to get slightly more complicated after this. So far we have done input, one number, two numbers, it can be three numbers, and then what to do with the second number, either to add or to subtract and output the numbers. Next, what we're going to do is load, store, similar to what we do in our computer system, what we call fetch and execute. Fetch means little man finds out what instruction he has to or he is to execute. Whether you got to take the letter and put it into the mailbox, that is fetch. Or take the letter from the mailbox, put it into the output basket, that is also fetch. Execute is something like that, he has to perform, meaning like calculation. Like what you did in your program earlier, add, subtract is what you call execute. Input and output what you call fetch. I hope you understand the difference. Input, output is like fetch. Execute is something like you load, you add, you subtract. Okay. Fetch portion of fetch and execute cycle. Little man reads the address from the location counter. You go and read the counter, 25. He walks over to the mailbox, 25. That corresponds to the location counter. You see the counter says 25, he walks to the counter 25. And he reads the number on the slip of the paper. He puts the slip back in case he need to read it again later. Yeah. So that's what he is doing, isn't it? He reads the number on the slip of paper, which is at the mailbox 25. The contents of the mailbox 25 is 589. Yeah, 589. There is a paper there, and the paper is written 589. He puts the slip back in case he needs to read it again. After you look at the paper, you put it back here. But you remember 589. And then the instruction is the fetch portion of the cycle has to occur first, right? The fetch, meaning you fetch the numbers first. Until the LMC has performed the fetch operation, he does not even know what instruction he will be executing, right? So what the story here is, he has to go to the counter. The counter tells 25. What the counter tells him, go to mailbox 25. So he goes to mailbox 25 to see the contents the contents of the mailbox 25. Only when he's here, he pick up the paper and then he understood he has to go to mailbox 89. Because remember, the first character is a opcode, second character is the mailbox. Instruction, instruction. So then you will know what to do. So until you read the 25, mailbox 25, until he fetch, doesn't know what to do. So this is what he fetch, this is what he execute. After he fetch, he has to execute this contents 589. Then he will go here and execute in order to get the contents of 89. So here, what he does here is fetch. What he does here is execute. That is what the meaning of fetch and execute cycle. Okay, now we're going to do one additional step. Same, the little man goes to the counter. He pick up the number 25, then he goes to the 25. He knows there is a content there, 589. The little man goes to the mailbox 25. Specified in the instruction, he just fetch. Yes, go and fetch. So next he has to execute. He reads the number in that mailbox. He remember it's 589, but then he put back the paper there so that he can read later, just in case. Then he has to execute. What he has to execute? 89. So now he's going to 89 to execute. So when he goes to 89 and try to execute, what he found out, the contents of 89 is 222. He walks over to the calculator and punches the number 222. You see, he's executing, isn't it? He's executing the contents of the mailbox 89. He walks over to the location counter and he will change it, yeah, to the next instruction 222. That's what he's doing, lah. So this is what we call fetch and execute. Yeah, fetch and execute. So in every instruction or every code that we write in our programming language, basically this is what we are doing, isn't it? We write an instruction, we execute. We write an instruction, we execute. So what your memory will do, try to compare this with your computer system that you have today. Yeah? What will happen to your computer system, your laptop, your devices that you have today? When you press a function on your keyboard, that function, for example, when you press F5, F5 will fetch an instruction from the memory, load into the CPU to execute. Yeah, to execute. Then the CPU will execute accordingly. Okay, let me ask you a question. I'm going back to the chat box. Okay, type for me. Type for me. Can we execute instruction at the memory? Can we execute instruction at the memory? Yes or no? Can you execute an instruction at your main memory? RAM? Yes or no? Type yes or no. Kajendra say no. Kwe say no. Brian say yes. Okay, for those who are saying no, where can you execute your instruction? If not at the main memory, where you execute your instruction? Type. All right, good. I see Lao type processor. CPU, right? CPU. Okay. So CPU is where you execute your instruction. Memory is where you fetch your instruction. So that's the difference. CPU has so-called no memory, so it doesn't keep anything. CPU is just like a calculator, empty. You have to enter the value, but the calculator is ever ready to process. It's the same like CPU. CPU is ready to execute. Yeah, but memory is ready to give you the instruction. That means you can fetch from the RAM and you execute in the CPU. That's the difference. Because many students fail these papers because you yourself get confused. What is the function of RAM? What is the function of hard disk? What is the function of CPU? What is the function of control unit? You're not very sure. You're not very sure. That's the reason why you fail. So this course is all about making sure that you really understand what is exactly happening at each component of the system, so that you can do programming at the very low level, at the device level. Otherwise, you go and execute the wrong thing at the wrong device, it can go haywire, really dangerous. For example, let's say you have to program to explode something. You go and program it wrongly. Things will go wrong, isn't it? Very badly. Yeah. So that's the whole idea. So remember, I will ask you guys next week, what is the function of the RAM? RAM is simply to store and to load, unload, or we call it fetch instruction. And if you want to execute any instruction, you execute in the CPU, ALU. For example, 2 plus 2. The 2 you store in the memory. The second 2 also you store in the memory. But the plus itself, addition, cannot take place in the memory. It only can take place at the processor. So you have to load the 2 into the processor, the first 2 and the second 2, and then get it calculated, get it added at the processor. The output 4 you store back into the memory. That's how things are. Anyone would like to say anything, or anyone would like to ask anything? That's why this subject is very simple, yet is very risky. You can go wrong, easily can go wrong.
I'm curious. I remember there's two types of processors, right? There's one's like memory processor, another one is like graphic processor.
Again, I didn't get your question. Two types of?
I remember there's two types of processor, right? Like CPU and GPU. One's like process the memories, the other's like process the graphic.
Okay. All right. Your question is right, and your answer is also right. Don't worry about that.
Okay.
If you are using game types of devices, of course, you will add on with more advanced processor to process the graphic media. For example, images, and audio, video, and so on. But normal processor, if you are just dealing with numbers and text, normal CPU, normal processor is good enough. Yeah. But both processors are doing the same job, executing instruction, not fetching. Yeah, not fetching. Of course, the fetching has to take place in the memory, load from the memory to the CPU, and then the CPU will execute. The output, the result will be load back into the memory RAM when the PC is on. But if you want to save further, then you have to click the save button to save it permanently into the hard disk. Otherwise, when you switch it off, everything will be disappeared.
Okay.
All right, anybody got any other question? Any clarification required?
Then 这个不是读书啊？这个是什么？
Meet your. Who's that? I am not very sure. I don't recognize your voice. Dinesh, is it? Mute your mic if you don't mind. Okay, let me continue. We have another 10 minutes before we branch out to your local site. Okay, that is to give you some understanding on fetch and execute. All right, so now we are at the point where we need to compare the real computers and LMC, which I already explained to you along the way. Yeah? The LMC is a very simplified computers when you compare to the real computers, but the operations are the same until today. So please read through this slide. I'm not going to go through into very detail. So our very first computer architecture introduced by von Neumann in 1945, that is after the Second World War. He has come out with a very simple computers. He has come out with a very simple CPU, where it has memory to hold some data, or we call it instruction and data, or we call it programmer. And of course, not for me to discuss in detail over here. You should have covered all this in subject IT. What is required? What is required before we discuss next week is I'm going to ask you questions, or you can discuss with your local tutor during the breakout time tutorial. What is the difference between, let me go back to chat. You can ask your tutor if you're not very sure, what is the difference between 32-bit computers versus 64 bits? We call it architecture, isn't it? Yeah, architecture. I'll ask you this this question next week. What is the difference between 32 bits and 64 bits architecture? Anyone has an answer? Would you like to share now? What's the difference between 32 bits and 64 bits architecture?
64 bits can handle more data at once.
Are you referring to memory or CPU?
Memory, something like that, memory.
So the 32 bits and the 64 bits, when you buy laptop or software, nowadays is all supported by software, you are referring to memory, not processor.
Oh.
Okay, if you don't have the answer, it's okay. Please clarify with your tutor or do some homework what it means by Intel 64 bits processor or 32 bits processor. Intel, I did mention the word Intel. The moment I mention the word Intel is all processor or memory? Intel owns processor or memory, guys?
Processor.
Processor. So please, processor. Intel doesn't do so-called, their core business is not memory, their core business is all processor. So I'm not saying it's wrong to refer to memory, but it's more proper. The architecture itself is actually belong to processor. It belongs to processor. That means whether your computer can, I don't want to give you the answers, but I prefer more detailed answers from you guys next week. What is the meaning of 32 bits architecture versus 64, or even our servers today are running on 128, 256 and so on. So I will pick up randomly next week some of you, I don't know who, maybe can be from Penang or SJ or KL. I want to know things like what it means by 32-bit architecture, 64-bit architecture, what it means by 64K memory size or 1 terabyte, all the basic stuff. You need to qualify yourself. You need to certify yourself before you can pass my exam. This is a 100% exam. And also I would like to ask you some basic questions on number system. Remember I asked you earlier what is A, what is B, ASCII table. So please do some homework before I talk to you all next week, so that all of us are on the same boat. Give me a minute, give me a minute. Okay, so basic is very important for this course before we go further. Many of us are living in the world where we think we know. But if I ask you basic question, of course we can go very advanced, but if we don't know the basic, it's actually not so good for us as IT guys. So we need to know the basic, what it means by gigahertz, what it means by terabytes, what it means by 32 bits versus 64, what it means by dual core, double core, what it means by for example, if you see Intel now, they have DDR RAM. Then what are the terms they use for memory? Okay, sorry about that. All right, so basic. Okay, before I end the class today, because 5 to 6 is our local tutorial, we will do a BRZ, yeah? or BRP, branch on positive. So all of you also need to know what are the mnemonics or code that you learn in the assembly language today before we go into more complicated assembly program in the coming week or in your tutorial. Any question?
No.
Okay, Brian, thank you. Anyone else?
So far, okay, sir.
Okay, good.
No questions so far.
All right, thank you, Leong. Okay, if no, take a short break, maybe 5 to 10 minutes, because you have to exit this meeting and you got to join the local meeting. I'll talk to you all next week, same time, yeah, same meeting invitation. If you have question, you can stay back. I'll be until, yeah, the link is up. So also I'll put up the recording sessions. Otherwise, it will also be available in the chat. So I need to take a look at all this chat to capture your attendance, as well as, yeah, if there is any other message, important message, you can capture here, and the link also is there. Thank you for someone who put it up.
Sir?
Nurul, okay, the lecturer. Thank you very much, Ms. Nurul.
Sir?
Yeah, anything?
I have a question, but this is regarding our exam.
Yeah.
So in our exam questions, right, our questions will be like short description answer, or will it be like essay questions or calculation question?
No essay, no essay. It's all structured questions. Like what I explained last week, you might have a question with 10 marks. You might have a question with 25 marks. You might have a question with 5 marks or 2 marks. So you need to answer the questions based on the marks. If 2 marks, 2 to 3 lines. If 10 marks, maybe like 15 lines. So it's a short answers. One of the students did ask me, can we use point form to answer? Yes, you can, but elaborate your point. Don't write too short, because If you write too short, we give you short marks. If you write good explanation, definitely we will try to give you more marks. The marks will be given by us, by the local lecturers, because we will be the one marking your papers first, the first round. Then we will upload the marks to UOG. They will go through it for second marking. Did I answer your question?
Yes, sir. Thank you.
Okay, thank you.
So basically, the more detailed, the better.
Better, because there is a no what we call, if you write a wrong thing, we don't minus mark. So why don't you write more? You see, you have 3 hours. Make use of the 3 hours to write as much as you can. If you write it wrong, we are not going to minus mark. That's the beauty about it. But if you don't write anything, you don't get anything. So might as well you write something. At least we will give you 1 or 2 marks, and then you gain marks. So my suggestion always is write more. If it is wrong, it's okay. Don't worry. We're not going to minus marks. But if you don't write, that's a problem. We cannot give you any marks. So always write more. Okay, guys, it's 5 o'clock. Let's stop here. I'll talk to you next week. Let's break up. BRZ. Thank you. Bye-bye.
Thanks, sir. One thing, where is the Subang Jaya link?
Is the Subang Jaya lecturer here? I can't remember the name. Subang Jaya.
The link is already in Teams already.
Okay. I see Penang link is here.
Penang
Subang Jaya link. Can someone put it up? I don't have the Subang Jaya link.
Do me a favor, please. Thank you. Sorry.
Penang link is up. Subang Jaya link, someone can put it up. I only have the CARE link. Sorry about that. Okay, guys. Thank you.
Thank you, sir.